Hello children, so welcome to AIMS India's online classes. Today from polynomials, from mathematics subject, polynomials topic we are going to discuss. So in our previous video children, we have learned the graphical solutions of linear polynomials and quadratic polynomials. How to represent zeros of linear or quadratic polynomials on the graph paper that we have learned. So based upon our previous examples, based upon the shape of the graph y equal to ax square plus bx plus c, there may be three cases possible, or three cases can happen regarding the zeros of polynomial. Case one is the graph means the parabola, either open downwards or open upwards. The parabola, which is the shape of this quadratic polynomial, it may cut x-axis at two distinct points. At two distinct points, one is A, another one is A dash. That is the first case. Means our parabola, whatever quadratic equation is there, if we represent it with the help of a parabola, it may cut x-axis at two distinct points, A and A dash. Means here x1 comma y1, x comma y value will be there. At A dash also x2 comma y2 value will be there. The x coordinates means x1 at A, x2 at A dash. The x coordinate values at A and A dash are said to be two zeros of the quadratic polynomial ax square plus bx plus c. The parabola, it can be either upward or it can be either downward. That is case one. Means in this way, it may be either downward or either upward, but it intersects x-axis at two distinct points. One is A, another one is A dash. Here also, one is A dash, another one is A. So if you draw a graph for quadratic polynomial, so case one, like this, it may be, the shape of the graph may be like this, according to case one. Case two, here in case two, the parabola, it touches the x-axis exactly at one point. This condition may also come across. Either a downward parabola or upward parabola, it can touch the x-axis exactly at one point. That is case 2. Means if you draw a curve for linear quadratic polynomial ax square plus bx plus c, then it will be in the form of a parabola just touching the x-axis, as we have shown in 1 and 2 diagrams. Means 2 points coincide with 1 point. 2 coincident points means 1 point. Look like 1 point only, or we can call that 1 point as 2 coincident points. 2 points are there which are coinciding with one another, looking like 1 point. So the 2 points A and A dash coincide with one another to become 1 point as A. At the A point only, we are also having A dash. Both of them, they are coinciding with one another. So this is case 2. That if we draw a parabola, if we draw a curve for a quadratic polynomial, like this solutions also we will come across. Means the parabola will be having two zeros which are equal to one another. Next, case 3. So if you observe this parabola and this parabola, these two parabolas, they are not at all touching x-axis. they are not at all touching x-axis, either completely above the x-axis or completely below the x-axis. So that does not cut the x-axis at any point. What does it mean? Means no zero. The quadratic polynomial is not having any zero in this case. Is not having any zero in this case. Because if you take the expression or quadratic polynomial x square plus 1 equals to 0, what is the solution for this equation? X square equal to minus 1, x equal to root of minus 1. So x equal to root of minus 1 is called I, imaginary number, or iota. Sometimes we call it as iota. X equal to I, which is an imaginary number. So there is no real number belonging to x, as in the case of this. So x does not have any zero in this case. No real zero involved in the value of x in this case. For this kind of equations, there will be no zero. There will be no zero. Okay, children. So what we have learned, children? What we have learned? If we have a quadratic polynomial, if we draw the curve, if we draw the curve for quadratic polynomial on the graph paper, three cases are possible. One is the curve, either upward or downward, intersect the x-axis at exactly two distinct points, means two zeros. That is first case. Exactly at one point, means 2 points coinciding with one another, either upward or downward, means they will be having only one zero. Two zeros are equal to one another. This case may happen. Or the curve doesn't touch the x-axis at all. It may be above the x-axis or below the x-axis, means no zero. It will be not having any zero. So in these three situations, any situation can happen. So geometrically, a quadratic polynomial can have either two distinct zeros or two equal zeros or no zeros. Or no zeros. Out of that three conditions, any conditions may be possible, children. Next, children, try this. Write three polynomials that have two zeros each. You have to write such that each polynomial will be having two zeros. Write one polynomial that has only one zero. How will you verify if it has only one zero? What is the verification? The curve should touch x-axis only at one point. So then we can tell that it is having only one zero. Write polynomials that has no zeros. So you have to try. You have to try and you have to write these polynomials, children. Next. So geometrical meaning of zeros of a cubic polynomial. Zeros of a cubic polynomial. We have learnt about linear polynomial, which is a straight line. Quadratic polynomial, which is a parabola, either upward or downward parabola. Now we have a cubic polynomial. So now we are going to learn the geometrical meaning of zeros of cubic polynomial. So cubic polynomial means degree, highest degree will be 3. X cube minus 4x. Let us assume it has y equal to x cube minus 4x. So x value, y value, x comma y value, x minus 2, y value 0, minus 2 comma 0, x minus 1, 3 minus 1 comma 3, 0, 0, 0, 0, 1 minus 3, 1 minus 3, 2, 0, 2, 0. Like that, x values, y values, x comma y coordinates, table we have to write first. And based on the xy coordinate values, we have to draw the graph. for this expression. So here, first point, second point, third point, fourth point, fifth point. If we locate 5 points on the graph paper with the help of coordinates, and if we join them with a smooth curve, it is coming like this. The shape is coming like this. So it is touching x-axis at minus 2, 0, 0, 0, 2, 0. 3 points whose x values are minus 2, 0, plus 2. So minus 2, 0, plus 2 are the zeros of the cubic polynomial. So minus 2, 0, 2 are the x coordinates of the points where the graph of y equal to x cube minus 4x intersect x-axis. So cubic polynomial will be having 3 zeros. So let's take some more cubic polynomials. One is x cube, another one is x cube minus x square. So let's construct the table for x cube. X, y equal to x cube, x comma y points, 2 minus 8, minus 2 comma minus 8, minus 1 minus 1, minus 1 minus 1, 0 0 0 0, 1 1, 1 comma 1, 2 8, 2 comma 8. And for second equation, x equal to y equal to x cube minus x square, x minus 2 whole cube minus 2 whole square, it is minus 12. So point is minus 2 comma minus 12. In the same way, minus 1 minus 2, 0 0, 1 0, 2 4. Like this, we have constructed tables for first equation y equal to x cube, another equation y equal to x cube minus x square. Now, if we draw the graph of y equal to x cube based upon these 5 points. So 1, 2, 3, 4, 5 points. How is the graph? It is touching x-axis at only one point. Only at one point whose x coordinate is 0. So 0 of the quadratic polynomial is only 1, which is 0. Whereas if you see here, the graph of this one, first point, second point, third point, fourth point. We have 1, 2, 3, 4, 5 points here. 5 points here. So 1, 2, 3, 4. Minus 2 comma 12 also somewhere. Minus 2, y value 12 children. Y value 12 children means somewhere it will be downside. Somewhere it will be downside. So this 1, 2, 3, 4. Sorry. Here. This one 1, 2, 3, 4 points. Minus 2 comma 12, somewhere it will be here. Minus 2 comma 12, 5 points. So this is touching x-axis at 1, 2 points. So one is 0, another one is x equal to 1. We are getting only 1 0 in this case. We are getting 2 zeros in this case. So in y equal to x cube, 0 is the x coordinate of only 1 point. So y equal to x cube intersect x-axis at only 1 point. The polynomial has only 1 0 in this case, which is 0. For second one, the graph is intersecting x-axis at 2 points, 0 comma 1. at 2 points 0, 0 and 1, 0, whose x coordinates are 0, 1. So cubic polynomial has two distinct zeros. Two distinct zeros means they can have 1, 0, they can have 2 zeros. They can have a cubic polynomial means it can has 1, 0, 2 zeros, 3 zeros. So at most, maximum, it will be having 3 zeros. It will be having 3 zeros. So a quadratic polynomial means maximum it can have 2 zeros. A cubic polynomial means maximum it can has 3 zeros. Okay, Jaran? So in the same way, we have to find zeros of these polynomials. These polynomials. Next, Jaran. So in general, a given polynomial p of x of degree n. Suppose if we have a given polynomial p of x of degree n, then we take it as y equal to p of x. We assume it as equal to y. And if we draw the graph of y equal to p of x according to degree n, it should intersect x-axis at n points. Means p of x of degree n should have at most maximum n zeros, or it can have less than n zeros, but maximum will be always n zeros. Here y equal to p of x is there. P of x is a polynomial. So if we draw graph of y equal to p of x, it may be like this as in first case. It may be like this as in second case. It may be like this as in third case. So what are the number of zeros intersecting at only one point? So 1, 0. Intersecting at 2 points, 2 zeros. Intersecting at 1, 2, 3, 3 zeros, 3 points, 3 zeros. So it will be having 1, 0, it will be having 2 zeros, it will be having 3 zeros. Like that, based on the graph, we can identify the number of zeros. So, first graph, the number of zeros is only 1 because it is intersecting x-axis at only one point. In second graph, the number of zeros 2 points. In third graph, number of zeros 3 because it is intersecting x-axis at 3 different points. Y means it is intersecting at 3 points. Intersecting x at 3 points, that's why 3 zeros. So fourth one, this graph, it is intersecting y-axis, that we should not consider. Only x-axis at how many points? 1 point. So number of 0 is 1. Here, touching at 1 point. So number of zeros 1. Intersecting at 1, 2, 3, 4. 4 points. So the number of zeros is 4. Number of zeros is 4. Like that. Just by seeing the graph, just by seeing the intersection points on x-axis, we can identify the number of zeros. We can identify the number of zeros. Next, find the number of zeros of given polynomials. Also find their values. So without plotting the graph, without drawing the graph, we can find the number of zeros. Let's see, children. So p of x equal, in the questions here, they have given p of x equal to 2x plus 1, highest power 1, linear polynomial. In second one, highest power 2, quadratic polynomial. Third one, highest power 3, cubic polynomial. Means we have to find zeros of a linear, quadratic, cubic polynomial without plotting the graphs. without plotting the graphs. So children, P of x equal to 2x plus 1 is a linear polynomial. It will be having only one zero. So to find zeros, we have to assume that the given expression is equal to 0. Then 2x plus equal to 0. X equal to minus 1 by 2. So 0 is minus 1 by 2. Like that we can find. Second one, quadratic polynomial. So it will be having two zeros. So given expression equal to 0. Y square minus 1 equals to 0. Which is in the form of y square minus 1 square. A square minus b square. A plus b into a minus b. Y plus 1 into y minus 1. Means the product of these two equal to 0 means first one equal to 0 or second one. Y plus 1 equals to 0 or y minus 1 equals to 0 or y equal to minus 1, y equal to plus 1. These two are the zeros. So the zeros of polynomial are minus 1 and 1. And for cubic polynomial, it has at most 3 zeros. At most 3 zeros we are telling. Maximum it can have 3 zeros. Sometimes there may be less than 3 zeros also. Like in this case. RZ, Z cube, RZ equal to 0, Z cube equal to 0, Z equal to cube comes this side means it will become cube root of 0. Cube root of 0 is 0. So the 0 of polynomial is only 1, which is 0. Okay, children? So, like that. So we have drawn graphs for cubic polynomials. Cubic polynomial, it can have at most 3 zeros. Sometimes it can have less than 3 zeros also. That's all for today, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. So please visit our website, children, www.aimstoday.in for other information regarding online classes, quizzes, live worksheets, do-it-yourself activities, English classes, coding classes, reasoning and art and craft. Thank you, children. Have a good day.